I think my recording is on. Just give me a second, guys. All right, that's cool. My recording is on. Okay, just confirm with me. Can you see my screen, guys?
Yes, we can.
All right, that's cool, okay, so let's proceed. So this on the first chapter, this is the thing that we actually have to go through so that you understand how to calculate a slope, or to calculate the equation of a line, as well as how to calculate the distance between 2 points, and also how to calculate the midpoint given 2 points, and also how to identify whether 2 lines are parallel or 2 lines are perpendicular. Okay, so the first example that I have, you're going to just have a look on the slope. How to calculate a slope? Always when we're talking about the linear equation, the linear equation is the equation that is in the form of what? Y is equals to mx plus what? Plus b. So whenever you've got an x value that you have the power 1 and a y value that you have the power 1, in any equation, you should know that it's a linear equation. So all the variables in a linear equation, they have got the highest power of 1. Once you find this one having the power 2, or any of them having the power 2, which means it's no longer a linear equation. So only a linear equation, you've got the variable of x and the variable of y having the power of what? The power of degree of 1. Once they don't have the power of degree 1, they've got the power of degree 2 or 3, it's no longer a linear equation. So the linear equation is in the form of y is equals to mx plus b, where this m attached to an x is what we call a slope. So whenever you write an equation in this form, you can easily able to pick up a slope from that equation. Say the slope is the value that is attached to an x variable, and the one that is a constant is the one that you say a y-intercept. So whenever you're given an equation in this form and you are asked to give what, and you get the question that is asking you what is the slope, you simply have to check on your value that is attached to an x, and that value becomes your slope. And if I ask you and say, what is the y-intercept? The y-intercept is simply the constant value that doesn't attach to any variable x or y. That becomes your y-intercept. So for you to do that, you need to write an equation in this form first, and then you'll be able to determine a slope, and then able to determine also an y-intercept. So these are form of what? Linear equation. So I have got an example that I put also in my screen here. If you check, guys, is saying 2y minus 4x is equals to 8. And the question I ask you and say, give me what is a slope of this equation, or what is a y-intercept. So for you to determine a slope or a y-intercept here, you need to rewrite this equation in this form of y. So we make y stand alone, which is y the subject of the formula. So how do you do that in this equation? Which means I need to take this minus 4x to the other side for me to left with what? With y only on this side, on my left side. So when I take this 4x on the other side, it will change the sign. So if you check, I have got minus 4x. So when it jumps the equal sign going to the right side, it's going to be a positive. It's going to be a positive what? 4x. So if I was having a plus here, let's say I was having a plus sign, so when it jumps this side, it's definitely going to be a negative. So that is the concept. That's how you actually change those any variable or any term that you have. When it jumps the equal sign to the other side, it changes the status. If it was actually a plus, it changes to a negative. So always you have to bear in mind when you are actually dealing with these linear equations when you are solving them. So if I take my 4x now, this side it becomes a positive. So when it becomes a positive, now I left with what? 2y. So for me to eliminate these 2 attached to a y, for me to left with y, because I need my equation to be in this form, which is y is equals to something on the right side. So which means I have to divide each term by what? By 2. So if I divide here by 2, and divide here by 2, and divide here by 2, I'm going to left with what? This is exactly what I did here, which means for me to eliminate to left with y here, I have to divide each and every term by what? By 2. So here it's what I left with when I divide. I now having y is equals to what? 2x plus 4. So now I can simply able to pick my slope from that equation. So which means I know that my slope is the value that is attached to an x, which is what? Which is 2. That's how I simply get my slope from that linear equation. So you need to rewrite the equation in this form so that it will be easier for you to pick up what? A slope and the y-intercept. I think I'm clear on that. So my y-intercept is simply the constant, which is what? Which is 4, which is attached to what? To, which doesn't attach to any variable. Okay, so if you were having minus here, you know that you pick that slope. What it means your slope is going to be minus what? Minus 2. So you take the value with its sign, which the value that is attached to an x with its sign. So it means that becomes what? A slope. So your slope, you take it exactly with what? With its symbol here to become what? To become here, your final answer is a slope. Okay, I think I'm clear on that. So the same applies if I ask you this question and say, what is the slope and the y-intercept of a linear equation? You simply have to rewrite this one in this form like what I did on top. Then after that, you determine what is the slope. The slope is going to be the value that will be attached to what? To an x. And then the constant that is actually going to also remain as a value not attached to any variable x or y. That becomes what? Your y-intercept. So that's how you actually finding a slope in equation, in any linear equation that you are given. You can simply rewrite in this form, and then you can simply able to identify your slope and the y-intercept. I think I'm clear on that. I need you actually to go through this one maybe later. You just actually take maybe I'm going to share maybe the slide with you so that at least you practice, you solve this one on your own, following the steps that I did on the example here. Okay, so let's move on. So you can also able to what to the linear equation is simply in a one variable equation that simply involves a letter. You might also encounter a linear equation that doesn't have a y but having only an x. So you might also encounter a linear equation that have got a y but without an x. So if the question comes and say, what is the value of x? Solve for x. Maybe you're given this equation and then I ask and say solve for x. How do you solve for x here? This here is simple. You know what to do. You simply have to come here, then you jump what? If I have to rewrite here a little bit. So what you have to do here when you are solving, you simply have to take what? To take x. So if I say x, you simply have to say x is equals to what? Is equals to, which means when you are solving for x, this 2 is going to be, you're going to take this 2 and jump it to the what? To the right side. But when it jump this equal sign, obviously it's going to change the sign, what I told you, and say each and every variable or term, when it's jumping the equal sign, is going to change the status. So if it was a positive, when it jumps the equal sign, it's going to be a negative. If it actually a negative, if it jumps, it's going to change the status to be a positive. So this 2 is a positive. So when it jumps to the other side, it's going to be a negative. So my answer for x is simply going to be 5 plus minus what? Minus 2. So that's how actually it's going to be. So because this 2 jumps to the other side now, it's going to be a minus. So 5 minus 2 is simply going to be equal to what? It's simply going to be equal to 3. So that's my value of x. So if I say solve, we are given this one and say solve for x. You simply have to know how to solve it, which means you are simply take these 2 to the other side, and then you subtract each other, then your final answer is going to be what? To be 3. So that's how you solve it, which is simple as that. So if you are given also something like this and say solve for y, it should be simple as well. You have got y minus 12 is equal to 0, which means what you have to do now, this 12 is going to jump to the other side for you to be able to determine what is y. That's why actually when you're saying solve for y, we need you to determine what is the value of y in this linear equation that you are given. So the same applies. You are simply going to have y, then you jump, which means you have got 0 here, which is already on the right side. So I'm taking 12 to the other side. So when it comes, because I have got minus 12, so when it jumps to the other side, it's simply going to be plus what? Plus 12. Which means my value of y is equals to what? My value of y is equals to 12. So that's how you solve those simple linear equation that you have got only one variable. The same applies this one. You can do the same actually, which means here you can also jump. When you jump on this one, you're simply going to jump this one, which means you're going to have 2y. 2y is equals to what? 2y is equals to 0. 0 plus 5, because this 5 is a negative. When it's jumped to the other side, it's going to be plus, which means it's going to be plus what? Plus 5. So which gives you, so now you have got 2y, you have got 2y, is equals to what? Is equals to 0 plus 5. 0 plus 5 is simply going to get 5. So for you to get y here, which means you have to divide, which means your final value of y is simply going to be y is equals to what? Y is equals to 5 divided by 2. That's your value of y. That's how you find it. So here you have got 2y is equals to what? Is equals to 0 plus 5, which is 2y is equals to 5, because 0 plus 5 is 5. So now you want to eliminate these 2 so that you left with y. So we divide each term by what? By 2. That's why you get what? That's how you get y divided by what? Divided y is equals to 5 over 2. So as your final answer. So all those simple linear equations, you should be able to solve them. It's very simple to actually get the value of what? The value of your y or the value of your x when I give you those simple equations. And those linear equations, if you are asking about the slope or the y-intercept, you should also be able to what? To determine them, which is actually very simple. It's not actually difficult on this linear equation. Okay, I hope I'm clear on that. So this is actually some of the examples that I need you actually to solve at your own time. When you get this slide made after the lecture, you can actually go through this question. Try to apply the concept or the steps that I actually did on my examples there. Then to try to solve also this one, to play around, to apply to see whether you can actually able to what? To solve them. If I say also determine, the question is actually simply say determine if these following equations are linear equations. Are these linear equations? You should know how do you determine whether an equation is a linear equation. I told you and say linear equation, if you have got a variable x, a variable, what we call a variable is this x's or the y's that we have. We call them variable. So in a linear equation, the power of the x and the y that are in your equation, if you have got the x or y, any term that you have, any variable that you have in your equation, the power of that variable must be the power of 1. It must be the power of 1. If it has got the power of more than 1, which means it's no longer a linear equation. It's no longer a linear equation. So if I say determine whether this one are linear equation, so you check the powers. So if I check on this one, I have got x here, which is my variable. If I check the x, I've got the power 1. It's not having the power of more than 1, which means this one is qualified to be a linear equation. Why? Because it have got x variable that have got also the power of what? The power of 1. So that's how you determine that. So I can come on to the second one, which is this one. Now, if I ask you, is this one a linear equation or not? I can check also here. If you check my x, I have got x variable, but x variable is the power 2. But linear equation is now transgressing the characteristic of this equation of being a what? A linear equation. For it to be a linear equation, it must have the variable of the power 1. But this one now you have got the power 2, which means it's no longer qualifying to be a linear equation. This is not a linear equation at all. So you can actually take this one out as not a linear equation. Okay, I came to this one. I'll check my variable x. My variable x is to the power 1. Also, my variable y equals the power 1. So this equation qualifies to be a linear equation. It's a linear equation. So that's how you determine. I came to this one now. If I ask you, determine whether this one is a linear equation or not. You can come here, you check my variable x. If you check my variable x, I'll see my variable x, you've got the highest power of 1, which is okay. Then I'll come to another variable that is also part of the equation, which is y. Y, you've got the power 3, which is now against the law of this equation qualifying to be a linear equation, which means this equation is no longer a linear equation because y, you've got the power of 3 instead of the power of what? Instead of the power of 1. So that's how you eliminate it. So you should be able to identify also the linear equation and the non-linear equation, whether the equation is a linear equation. I think I'm clear on that. I think everyone understood on that. Okay, let's move on to the next part. I think the next part we just want to show you how to solve what? Okay, it's the same equation. I already showed you how to solve for x. So it's not much actually something new. To solve x, if you are given any question like this one, how do you solve x? You simply have to take this one to the right side. I already showed you. So I'll take this one. I want to find the value of x. So I'll take this minus 6. When it jumps the equal sign, so the equal sign it's mainly called the magic. It's the magic river, the magic gate. So anyone who jumps it will change the status. Okay. So once you jump here, you've got negative. You jump that other side, which means you become what? You become positive. If you were negative, if you were positive, once you jump that equal sign, you become what? You become positive. So that's actually what happens here. So -2 is going to jump. minus 6, I take it to the other side. Once I take it to the other side, it's going to change the status. So now, instead of being minus, it's going to be positive. So that's how I have plus 6 here. It jumps and becomes positive. So I'm now left with what? Minus 2. So how do I eliminate this 2 on my what? On x, so that I'm left with on x? That's where I have to divide. So how do I divide now? You have to divide both sides. So here, if I say 8 plus 6, I'll get what? 14. So which means what I'm left with is 2x is equals to what? Is equals to 14. If you check here, that's exactly what I have. So now I want to eliminate 2 so that I have the actual value of x, because the question might come and say, give me the actual value of x. What is x? So when I say what is x, we need to find the x, the value of x variable, a standalone, without actually combining with other maybe quantification or other variables. Like here I have the quantity of 2x. I need only the value of x. So I have to divide this by 2. Pardon, there's someone, is there anyone who have got a question? Are we on the same page, guys? Just to confirm.
Yes, sir.
All right, cool. All right, cool. So here, if I have got 2x is equals to what? 2x is equals to 14. I need to eliminate so that I left with what? Only x. So I divide this one by 2. If I divide by 2, which means I'm going to left with x. So whatever I do here, I'm only have to do the same on the other side, which means if I divide by 2 here, I need to divide also by 2 on the other side, which is what? Which is the right-hand side. So when I divide 14 by 2, I'm simply going to get what? 7. That's how I'm getting my value of x, which means my value of x is simply going to be what? Is equals to 7. So that's how you actually solve for any value. If I actually told you to solve for a value, if you get a question that is give me the value of x from this simple equation that we have, you should actually be able to do that. So I think actually it's also easier on my side from what I actually explained now. You can actually able to go and solve this question that is here, and say solve the following question for y. If we solve this one, I think also you have to solve it on time following the same concept that I already mentioned here. Okay, so this is how solve. I want you to go through it maybe later. Once you did the lecture, I'm going to upload the slide as well. Okay, all clear, guys? All right, so let's move on. So let's say now you are given maybe two points on a graph. Then you are asked to calculate a slope. A slope is also what you call a gradient. So whenever you're given 2 points on a graph, 2 points, when I'm talking about the 2 points, I'm not sure if you are, I assume that everyone went through the whole chapters for now, and you know about these things. Okay, so whenever you're given 2 points of your graph, and then you are asked to calculate a slope, you should also know how do you calculate a slope from what? I think there's someone who have got a mic that is on. I'm not sure if you were trying to raise a problem. If you have got any question there. If you don't have any question, just kindly mute your mic, then you unmute it when you want to maybe ask something. All right, so if you are given 2 points, then you are asked to calculate a slope. You should be able to also calculate a slope, or know how do you calculate a slope from given 2 points. So the formula is simply, the slope we normally present with the symbol m. M is simply going to be your y2 minus y2 minus y1 divided by x2 minus x1. So that's how you calculate what? A slope. So a slope, sometimes you call it a rise over what? Over run, or sometimes you say how far you go divided by which direction. Okay, that's how you calculate when you apply maybe the concept of physics. When you actually want to determine also the slope in concept of physics, when you are throwing a ball on all those things. Okay, but we're not talking about that now. We just focus on what? On the concept of what? This simple formula, that is whether when you're given 2 points, how do you calculate a slope? I have an example that is here. Let me explain using my example, saying I have 2 points, and the question posed to you and say, find the slope of a line passing through points, which is this one and this one. So always you should know, whenever you're given a point, one of the point is representing an x, and the second point is one of the value, and the second value in a point is representing a y. So this is the y value, and this one representing your x value. And also the same point here, the first point in your 2 points coordinates that will be given, the first coordinate is the x coordinate, and then the second one is the y value, which is the y coordinate. So that's what you have to know. So when you are picking on this one, you simply have to consider these 2 points as what? 2 points as you have in your x, y, y, x. Maybe you label this one as your first point, and then this one is the second point. It doesn't matter which one you want to take it as a second and which one you want to take this as a first. The answer that you're going to get is the same whether you simply use this one as your x2 and y2, and this one as your x1, y2. It doesn't actually change your answers. You choose which one do you want to take it as what? As your y2, and which one do you want to take as your x2, okay? So, for example, if I take this one as my first point, and this one is my, and this one is my second point, which means this one becomes my y2, and this one becomes my y1, and this one becomes my x2, and this one becomes my x1. So when I'm calculating my slope, I simply use this concept, which means in place of y2, I'm taking the value of y on my second coordinate. Then I was putting this one and saying my y2. You see, I'm listed here and say, I'm taking my y2 as what? Okay, that's all. I put the wrong values here. Let me change my coordinates. Let me take this one as my y2 as my y2. Okay, it's the same 2, is 2, because that is the one that I used on my calculation here. So here is simply my y2 is going to be 2, which is, I'm saying y2, which is 2, minus y what? y1, which is what? Which is 6. So y1 is 6. So when I'm calculating my slope, I'm saying y2 minus y1, which is y2 minus y1, which is 2 minus what? 2 minus 6, if you check here on top here. The one on top, which is 2 minus 6. Then I'll say divided by x2 minus x1. x2 minus x1, which means I need to, my x2 becomes what? Becomes 3. So x2 becomes what? x2, my x2 is equal to 3. That's why I'm saying 3 minus what? Minus my x1. My x1 is the first one coordinate, which is 1 here. So I'm saying x2 minus x1, which means I'm dividing. Once I'm saying x2 minus x1, it's simply going to give me, okay, it's simply going to give me 2 minus 6. 2 minus 6 is giving me minus what? Minus 4. So because 2 is the positive and minus 6 is negative. So when I'm saying 2 minus 6, I'm going to have left out with the bigger number on the negative side, which is 4 minus 4. So that's what I'm getting when I'm saying 2 minus 6. When I'm saying 3 minus 1, I'm going to get what? 2. So I'm dividing minus 4 over what? Over 2. If you divide, you're simply going to get minus what? Minus 2. So this becomes what? Your slope. So your slope, given 2 points, you should actually have to know, you say 1 point divided by minus the other point. But now when I'm minusing, you have to determine which one, the y on the second point minus the y on the first point. Then divided by the x on the second point minus the x on the first point. That's how you determine a slope given what? Given 2 points. I hope I'm clear on that. Okay? So when I get a question that you're given 2 points and you're asked to calculate a slope, it should be simple. You simply use the same concept, which is the same, this formula, to calculate what? To calculate a slope. I hope I'm clear on that. Okay? Let's move to the second one. The second question also, you might not also given what? Given the 2 points, you're given 1 point. And then the question comes and say, calculate, find the equation of a line. This is not actually asking about the slope, but it's giving you the equation of a line, which is the linear equation. You are given a point and you are given a slope. And you are asked to calculate the equation of a line. You should also able to know how do you calculate the equation of a line given a point and a slope. It should be simple to you. Okay? So which formula do you use? You use the formula that is called y is equal to minus y minus y1 is equal to m times x minus x1. That's the formula that you use. So what is m in this equation? M is a slope. So you simply, on place of m, you put a slope. And in your equation, if you check it, I'm already given a slope and say slope is minus 2. But what is x1? X1, you simply actually extract x from the point that you are given, which is 1. So what is your y1? Your y1 is simply extract the y value from the point that you are given, which is 2. So once you simply substitute your y1 here with your value of y1, which is 2, and then m with the slope that you are given, which is minus 2, and then x1 with the x value that you are given, which is 1, and then start solving to get your equation of that line. So when you are given a point and a slope, you should actually use this equation, which is here, to get your line of your equation or your linear equation simply from that point and the slope that you are given in your question. So it's actually simple for you as well. So how do you solve it after you substitute the values? Here, I put my 2 here in place of what? In place of x y1, which is this 2. So I put my 2. Then on the right side, I put in place of m, I put minus 2, which is what? Minus 2, which is the slope that I'm given in a question, okay? Which is the slope, because m is a slope. So on place of x1, I put the value of x1, which I have here as what? As 1. So I put it in place of that. So once I substitute those values here, I now start solving it. Solving it, I'm removing the bracket. Those brackets, how do I remove the bracket? I'll start with this side. So this side, for you to remove the bracket, which means you must multiply what is outside into the inside values. So how to eliminate the brackets? You simply take this value and say multiply by each and every value that is inside the bracket, which means I'm saying minus 2 times x. I'm going to get minus 2x. Then I'll say minus 2 times what? Minus 2 times minus 1. A minus times a minus becomes a positive. Always you should know when you are dealing with those signs. A minus sign times a minus sign it gives you a positive. So when I'm saying minus 2 times minus 1 is simply going to be plus 2. That's how I get plus 2. So on my right side now I have got minus 2x plus what? Plus 2. But on the left side now I'll just simply remove the bracket because I have got y minus 1. So y minus 2 is simply, this one is simply the same as 1 times y, 1 times what? Minus 2. So there's no need for me to have this bracket anymore because it's simply going to be y minus what? Y minus 2. It doesn't change anything. So now I need to left with only y. How am I going to left with only y on the left side? Which means something must be taken to the other side, which is minus 2. Minus 2 have to be taken to the other side. But remember, bear in mind now, here I have got minus 2. Whenever a value is actually jumping the equal sign, it will change the status. So when I have minus 2 here, and I'll take minus 2 to the other side, obviously it's going to change the status. It's no longer a negative status, but it's going to have a positive status. So that's how a minus 2 is changing to a plus on the other side. So remember, I still have minus 2x plus what? Plus 2, which is here. And then now this minus 2 goes to the other side and becomes a positive. That's how I have got plus 2 here. So after that, I simply now solving. 2 plus 2, because they are constant, I can actually combine them together. 2 plus 2 becomes 4. Then I can combine that one, becomes 4. But this one now remain because it's attached to what? To an x. Okay, so this becomes my equation of that line, which is a linear equation from a given 1 point and a slope. You should actually know how to get it, how to get the equation of a line given a slope and given what? Only 1 point. So that's how I actually calculate a slope. So I think actually it's understandable on the side as well. Okay, so in this equation, let me just pause it for a second to you. I'm posing a question. I have this one. Okay, it's not going to be a question, but I just want to confirm now. Did you see now on my equation is in the form of y? If I give you this equation now and I say give me a slope, do you see how you can pick a slope from this equation? Do you see this slope that is attached to my variable x? Because I told you and say if you are given any equation and I ask you a linear equation and ask you and say what is the slope? you should write the equation in the form of y is equals to mx plus what? Plus c, where y will actually become independent, not attached to n value, becomes only a y, left with y on the left side, and then you say is equals to any value attached to an x, then plus a constant. So when I say what is a slope here, you simply pick a slope as a value attached to your x. So that becomes a slope. So if you check here minus 2 is a slope because it's a value that is attached to an x. So if you check minus 2 corresponding with exactly the value that is the slope of what? Of the value that I was given in a question, which is minus 2. So if I say what is your y-intercept from this equation, y-intercept becomes what? Becomes 4. So the value that is attached, which is a constant in a what? In a linear equation, becomes what? A y-intercept. So the y-intercept is simply going to be what? To be this value, which is a constant, which is 4. So you should be able to pick a slope and what? And the y-intercept from a linear equation when I'm given a linear equation without even doing a calculations. When I'm given in a linear equation in this form, you should just pick up a slope there and pick up also a y-intercept from that constant. Okay, so that actually should be clear, I think, on your side as well. All right. So let's move on to the next part. The next part of our question that we need to address is distance. How do you calculate distance between 2 points? Whenever you're given 2 points or 2 coordinates, and you should also, the question comes and say, calculate the distance between these 2 points. Calculate the distance between these 2 coordinates. You should be able to calculate the distance between them given 2 coordinates. So if you are given 2 coordinates, you simply have to use a distance formula. So this is the formula that you have to use. So the formula is simply you have to take those 2 variables and then you combine together by a, you find the square root of them, subtracting the distance between each other, between the x coordinates and then the y coordinates, and then you combine them together. Then you find the square root of all of the total value that is combined together. So that's the pretty simple formula that you use. So this is the x1 minus x2. Then you set to the power 2. The answer that you are going to get, you set to the power 2. Then you add it with y1 minus y2 to the power 2. Then the answer that you are going to get here, then you set to the square root of that. That answer is become your distance between those 2 coordinates. So that's how you find the distance between 2 points. So I have the question that is there for you to understand how to apply it. You simply, the question say find the distance between 2 points, which is 2, 3, and what? And 1 minus 2. So to find the distance between these 2 coordinates, you simply have to identify your x. Your x are these 2 and this 1. These are x coordinates. And your y coordinates are these second values are your y coordinates. So now from the formula is simply the distance, simply the square root of what? My x1 minus x2, then my x1. Which one is my x1? I take the value of x, which is 2. Then I'll say minus what? Minus the second x, which is 1. Then the answer to the power 2. Then I'll say plus, now I'm taking the y coordinates. So my y coordinates, I'm taking the 3, which is the 3 that I have here. Then I'll say minus. Then, but this one have got minus as well. So, which means now I have got a minus, which is the 1 for the formula. And I have got a minus, which is the 1 also for this y coordinates, that is I minusing it from 3. So that's how I have minus what? Minus 2. But you have to know that minus and a minus, once you have got 2 minuses, they convert to a positive. So a minus and a minus, it will change to a positive. So that's how now on my second, I now have a plus what? Plus. So this minus actually transform to what? To a positive. Once you have got 2 minuses, they actually transform to a positive. So now I have got, if you say here, if you calculate and say 2 minus 1, I simply going to left with 1. So that's how I got this 1 to the power what? 1 to the power 2. Then I'll say plus. But plus here, I'm changing this minus and minus becomes a positive. That's how I have 3 plus what? Plus 2. Okay? I didn't combine. I simply wanted to show you step by step on how to move to the next. Okay? So here I have got 1 to the power 2. Then I come here, I combine it 3 plus 2. 3 plus 2 becomes 5. Now I have 5 to the power what? 5 to the power 2, okay? So 1 to the power 2 is simply going to be 1. If you calculate and say 1 to the power 2 is simply the same as 1 times 1. So 1 times 1, you get 1. It retains 1. It don't change anything. So, but 5 to the power 2. 5 to the power 2, if you calculate it, your calculator say 5 to the power 2, you are going to get 25. 5 to the power 2 simply means you are multiplying 5 2 times. Say 5 times 5. That's what it means. So 5 times 5, it will retain 25. So now I add them together. 25 plus 1, I'm simply going to get 26. So 26, the square root of 26, that's my answer. So the square root of 26 is simply my distance between what? Between 2 points. So I don't need you to solve. When you are calculating when you encounter such questions, that you need you to calculate what? To calculate the distance. If you find in a situation where we don't have an actual value that is standalone, that doesn't have commas or decimals, you can just leave it in set form. We call it in set form. You just leave your answer like this as your final answer. You actually answered. But if you want, you can go ahead and use a calculator to calculate the square root of what? The square root of 26. If you want, it's still fine. Then you get your answer is simply going to be 5.09 somewhere there. 5.099 is your what? Is your answer. So you can actually go ahead if you have time. But I don't encourage you that. You can actually leave your answer like this. Then it's fine. You get all the marks allocated for that. You don't have to stress yourself out. It's okay. But if you want, you can actually go ahead and also calculate with the calculator to give the actual value, actual root of that value. Then you put it, you jot it down. Then you give it as a final answer as well. But it's not actually necessary. You can actually leave your answer in set form just like this. Then you get your answer for that. Okay. I think it's understood on that, okay? So that's how I calculate the distance between two points. Whenever you're given 2 points, you should know how to calculate the distance. You simply actually substitute your values in this formula. Then you end up you substitute step by step until you get here, okay? So I need you, when I share this slide on the group again, go and answer this question using the same concept. The question is saying, find the distance between points 4, 3 and -5. So once you'll be able to solve, you should actually follow the same steps that what I did here and get your distance between those 2 points. Okay, I think I'm clear on how to calculate what the distance between 2 points. Okay, so the other thing that we want to talk about is the calculation of midpoint. How do you calculate a midpoint? A midpoint, as the name states, simply means how do you find the halfway between 2 points? How do you actually find the points that are in the halfway, in the middle of 2 points? So whenever you're given 2 points, which is this one and this one, and you say, give me the midpoints of these 2 points, the middle, which means for you to find the middle coordinates. How to find the middle coordinates? You have to divide the difference between each x and y value by 2. That's how you find the midpoints. So that's simple as that. It's not actually difficult. So this is how we find the midpoints, which means you simply have to say x1 plus your x2, then divide by 2. Then y1 plus y2 divided by 2. So you are combining the x values and then you divide by them by 2. And then you are combining the y values and then you divide them by 2. Then what you are going to get is your midpoint. It's the point between those 2 values. It's the midway between those 2 coordinates. The midway between those distance between those 2 coordinates. That's how you get those coordinates at the midway, at the middle of that 2 coordinates. So you simply have to combine your x. So what is important? You have to identify which one are x values and which one are y values. I think everyone now is familiar. You can be able to identify from the coordinates. I told you and say the first value in a coordinates is representing the x coordinates, and the second one is representing the y coordinates. The same applies here, x coordinates. The second one, it's a y coordinate. So you can actually consider this one as your first coordinates and this one is made as the second coordinate. So when you are adding them, but for my calculation of my midpoint, I'll simply say my x1, which is 4, then I'll say plus what? Plus my x what? Plus my x2, which is -5. So if you check it, take that coordinate with its sign. Don't change that sign or don't try to play around with that sign. Put that sign exactly as it is so that you won't be actually find yourself getting a wrong value. put that one as it is with its sign. I'm taking -5 with sign, which is actually 4 plus -5, so that you'll be able to know when you are adding them with their signs, what actually value are you going to get. So make sure to take it with its sign. Don't actually make mistake of leaving the sign of any value that is actually part of your coordinate. Okay, so I'm now adding also the x coordinates. X coordinates, I have got my first y coordinates with my y coordinates. I'm adding my y coordinates. So my y coordinates, my first y coordinates is 3. I'm taking 3 here and I put here, and I'll say plus the next y coordinate is -2. So I'm saying plus minus what? -2. So I say divided by what? By 2. And here I will say divided by 2. So this is the formula. I'm simply substituting here into this formula for my midpoint. Okay. So once I actually put my actual values, I now start adding, which means 4 plus -5, which means is the same as 4 minus 5. So if I say 4 minus 5, I'm going to get -1. So -1 is the result that I'm going to get. If I say 4 plus -5, if you use your calculator and say 4 plus -5, you are going to get -1 is your answer there. If you use your calculator, that's what you're going to get. So it's the same as 4 minus 5, which is -1 that you're going to get here. So what it means is you're going to get -1 over what? Over 2, which is -1 over 2, the same as minus half, which is the one that I have here is my final answer is on the first place. Okay, so the second coordinate of my y is simply going to be 3 minus 2. 3 minus 2, I'm getting 1. Then 1 divided by what? By 2. So I'm simply going to get what? To get half. So this is the middle. This is the middle point between what? Between 2 points. So that's how you get it. So this is my final answer, which is -half and what? And half. So this is the middle point between these 2 points that I have. So whenever you're getting a question that you've got 2 points and then you're asked to calculate the middle point, you should actually use the same formula that we used here, which is this formula. You are adding your x's together and you divide them by 2, and you are adding your y's together and you are dividing by 2. Then you simply actually solve them and you get your middle coordinate, which is -half and half if for example in the calculation that we did now. So it should actually a symbol on your side as well. Okay, so I need you also, when I share the slide, do the same using on this question that you're actually saying, find the midpoint between the points 1, 3 and 4, 8. I need you to calculate the middle point between these 2 points using the concept that I showed you how to calculate the middle point between 2 points. Given 2 points, you should be able to calculate those middle points. Okay, I hope everyone is going to be able to do that. Okay, so do the same when I share this slide with you. Go and calculate using the same concept. Okay, so the next thing that we want to talk about is parallel lines and perpendicular lines. How do you determine whether the 2 lines are parallel or 2 lines are perpendicular? You should know what is parallel when we're talking about the parallel, what are perpendicular when we're talking about, what are perpendicular lines when we're talking about the perpendicular lines. Okay, so because you might actually encounter a question a question posed to you and asking, maybe giving 2 lines and asking and saying, are these 2 lines parallel or are these 2 lines perpendicular? Then you need to judge them. How do you check whether 2 lines are parallel or perpendicular? Let's talk about parallel first. Parallel lines have the same slope. So 2 lines that are parallel, they are always having the same slope. So if one line you've got the slope of -2, the other line that is parallel to it must have also the slope of -2. So the lines that are parallel, they are always having equal slope. So the slope of parallel lines are the same. So if one line have got the slope of 1, which means all the lines that are parallel to that line must have the slope of 1. So that's actually what you have to test or determine in any equations. For you to determine whether 2 equations are parallel or more equations are parallel, you need to check their slope, to calculate their slope. And once you find that their slope are equal, then you can actually conclude and say these lines are parallel. Why you say are parallel? Because their slope is the same. That's how you judge. Given any equations, then you can actually determine whether those equations are parallel or not. Okay, so for example, that I have here, I have this equation that is saying y is equals to 2x plus 2, and I have the second one that is saying y is equals to what? 2x plus what? 2x plus 10. So, but if you check these two equations, they are different. Why they are different? The other one you've got a plus 2 and the other one you've got a plus 10. So they're different. Okay? So if I ask and say, are these two equations parallel? You should be able to judge from them. I'm saying they're parallel. So the first thing that you have to do, you have to determine the slope. What is the slope of this equation and what is the slope of this equation? I told you from the previous discussion, I did mention that if you write your equation in the form of y is equals to mx plus c, you can be able to pick up a slope from that equation. So a slope is the one that is attached to an x value. That is a slope. And the one that is constant becomes a y-intercept. So if I check here, I have got a slope of 2, which is the 2 is the value that is attached to what? To x here, which means my slope for this equation is what? Is 2. But if I come to this one, my slope also is the value that is attached to an x, which is what? Which is 2. So this equation, you've got the slope of what? You have the slope of 2. And this equation also, you have the slope of 2. So I can conclude and say these two equations are parallel. Why I'm saying are parallel? Because their slope are the same, which is 2. But once they are changing, if I change, let's say, for example, I put this one as, maybe this equation you've got is in this syntax minus 2 is equals to x. If you check these two equations now, they're different. This one, you've got the slope of what? If I check this, the slope is what? Is 2. But this one now, the slope of this equation is what? It's perhaps minus 2. So when I say, if I ask and say, are these two equations are parallel, I can conclude and say they are not parallel. Why? Because their slope is not the same. This equation, they've got the slope of what? Of 2, and this equation, they've got the slope of minus 2. Therefore, since their slope are not the same, these two equations, they are not parallel because their slope is not the same. So that's how you judge from two equations, whether they are parallel or not. You can just judge using their slope. You check their slope and then determine whether they are parallel or not. If their slopes are the same, then you can judge and say they are parallel. So that's how we check from parallel. So I think I'm clear on that. I need also, you might also, I've also the other question that is here, okay? I think it's also need calculation. You might not only given the equations, you might only also given the points. You should know already we did actually an example of calculating the slope from given points, okay? So, for example, I have got this question that is here. If you check this question, it's saying, the one line is called L1, and the second line is called L2. So the question is are the two lines L1, which is I've got the points -2 and 4, 3, and L1 and L2, which passes through what? Through this point and this point parallel. So the question is simply asking whether L1 and L2 are parallel. But here you are given in the question, say L1 is passing, you've got these 2 points, and L2 also you've got these 2 points. And you are asking now, the question is giving you L1 and the points, 2 points of L1, and giving you L2 and the 2 points of L2, and is asking whether these two lines L1 and L2 are parallel. So what do you have to do? You determine the characteristic parallel based on the slope. So you have to determine the slope first. So which means you need to calculate the slope of L1, and then you calculate the slope of L2, and then you compare those two slopes, whether they are the same or they are different. If you find that their slopes are the same, you have the same value, then you can actually conclude and say these two lines L1 and L2, they are parallel because their slope is the same. But if you calculate and find that their slope are different, then you can conclude and say these two lines L1 and L2 are not parallel because their slope is different. Their slope are not the same. Then you can actually conclude. So here I did calculation. Here, if you check on my example, I have the slope of L1. I'm saying L1, you know already, you did went through the process of calculating the slope, okay? How do you calculate the slope of L1 given 2 points? I'll simply say Y1 minus, I simply say maybe Y2 minus Y what? Minus Y1 divided by X2 minus X what? X1, okay? That's what I'm doing here, 5, which is this 5, minus what? 5 minus 1 divided by 4 minus 2. Always take that with its sign. That's why I have minus 2 here. If you check here, it's minus for the formula and minus 2 for the value that I have here, which is minus 2. Okay, so it gives me, if I say 5 minus 1 here, it gives me what? It gives me 4. If I say 4 minus minus 2, it changes this minus. 2 minus, it becomes a positive. So it becomes 4 plus 2, okay? So that's how I'm going to get it. This one is 2 over 3. So the slope of my L1 is simply going to be 2 over 3. So 2 over 3 is my slope of L1. Now I need to calculate the slope of L2. Slope of L2, my focus is on the points of L2, of line 2, okay? So I'm taking this one as my second values, okay? So I'm saying Y2, which is minus 2, minus Y1, which is 0, okay? So minus 2 minus 0, divided my X2 minus my X what? My X1, okay? So I'm saying 0 minus what? Minus 3 divided by 0 minus 3, okay? So minus 2 minus 0 is simply retain minus 3. It simply retain minus 2, okay? This is minus 2. So 0 minus 3, it's retain minus 3. So I'm simply going to get minus 2 divided by minus what? Minus 3. So minus divided by minus, it cancels each other, and then it becomes positive. So this minus on top and minus at the bottom, it cancels each other. Then it's going to retain only 3 over 2, which you have got a positive. So if I check my final value, my final slope for L2 is the same as the slope for L1. So if I ask you, are the two equations parallel? It becomes simple now to judge and say, yes, they are parallel. Why? Because their slope are the same. Both of them, they have the slope of 2/3, which means I can conclude and say these two lines that are passing through different points, they are parallel to each other because they have the same slope. So I think it's clear to you now. Whether you are getting any question asking you about the parallel, you should be able to judge whether those two lines are parallel based on the calculation of the slope. I went through 2 examples already. Okay, so I think I'm clear on that, on the slope as to you guys. Okay, any question from your side for now? Any question? Just
Hello?
yes, I can hear you.
It's course here. No questions except that I acknowledge 1. 2, are we going to get these notes?
I'm not sure. Is everyone have access to? You have access on your Teams platform or the Teams group?
Looks like I don't have access. I've mentioned it before. Looks like I don't have access.
Okay.
Unlike first semester where I was able to view all the videos from the previous classes,
Okay.
view all the material that we used on previous classes.
Oh, all right. No problem.
This year I don't have. This semester I don't have it. I don't know if you can specifically send it to me on email, please.
Oh, okay. You know what I'm going to do at the end of this lecture? Stay with me. I'm going to share with you on my details. I'm going to display my details, my email and my contacts, so that anyone who can't access it from the group, you can just even communicate with me and say, hi, I'm requesting for the slide, then I'll send you the slide.
Thank you.
Okay. All right. Thanks for that. All right. Let's move on perpendicular. We just want to check on perpendicular. how do you determine whether also two lines are perpendicular or equations are perpendicular? So perpendicular you determine by also checking their slope. But how do you check their slope? You multiply two lines or two equations are perpendicular when the multiplication of their slope is giving you -1. So for you, when you are given two equations and you ask the question and say, are these two equations perpendicular? You need to find their slope, and then you multiply their slope to each other. And if you get the result of -1, then you can actually say they are perpendicular. But if you multiply their slope and get another value that is not -1, then you can actually give a conclusion, say these two equations are not perpendicular. Why? Because the results of their multiplication are not, of their slope are not giving you -1. So that's how you determine also the perpendicular of what? Of two lines. Two lines are perpendicular if their multiplication of their slope are giving you -1. If their multiplication of their slope are not giving you -1, which means they are not perpendicular. So that's how also you determine perpendicular, okay? I have an example here and saying, I have got the example that is saying y is equals to, I have the equation that is saying y is equals to what? X plus 2. And the other one saying y2 is equals to -x plus what? Plus 20. So how do you find the slope of this one? You can also pick the slope from this equation, isn't it? I told you that the slope is the one that attached to an x. So 1 is the one that attached to an x is simply 1 here. The absence of anything on x is simply there's 1 there. So that 1 becomes what? Your slope. That 1 becomes a slope. But we don't write 1 here because the x is simply the same as 1. If you have got 1 orange, you can't say you can't say right and say 1 orange. You simply say 1. Because simply I have an orange. You can't say you can't actually write the quantity when you have 1. You simply say I've got an orange. I've got only I'm only 1 orange. Sometimes you don't write the quantity because it's only a single item. It's listed as simple. You start writing the quantity when you have got more than 1. Okay, when you have got 2, it's where you can actually write 2 in most of the situations. You write the variables. Okay, so this variable is simply means you have got 1x. Okay, so that 1 that is here is simply becomes a slope of that equation, which is what? 1. So the slope of this equation is simply 1. So the slope of the second equation here, you check also the value attached to what? Attached to an x. I have got -x here. What it means, it simply means I have minus what? -1 quantity of what? Of x, which is simply -1x. That's what it means. But we normally don't write 1 if we actually have got a single. We start writing when there are more than 1, okay? So it's simply, my slope is simply going to be minus what? It simply means my slope is -1 here, okay? So if I multiply, since I want to check whether these two equations are perpendicular, I need to multiply slope 1 times the slope what? Times slope 2. This, what I put here simply means what? Multiplication, okay? I simply have to say slope 1 times the slope 2. They must give me -1. If I don't get -1, which means I can say these two equations are not perpendicular, okay? That's how you have to determine it, okay? So if I say 1 times what? Times -1 here, I'm going to say 1 times what? -1. I'm getting -1. Once I'm getting -1 as a result, then I can conclude and say it means this equation and this equation, they are perpendicular to each other. Why I'm saying they are perpendicular? Because their slope, when I multiply them together, they are giving me the result of -1. That's how you actually determine whether two equations are perpendicular. Just simple as that, okay? So, for example, if I was having maybe here, I was having -2. Let's say, for example, I was having -2. And then here, which means my slope becomes minus what? Becomes -2. So when I'm multiplying, I'm saying the slope, which is 1 times -2. If I say 1 times -2, I'll get what? I'll say 1 times -2, I'm going to get what? -2. So in this case, the equation is not perpendicular anymore. Which means now I can conclude and say the two equations are not perpendicular. Why I'm saying are not perpendicular? Because their multiplication here are giving me -2, which is not -1. Because always perpendicular equations, when you multiply their slope, they must give you -1. That's what you actually have to know. they must give you -1 to show that they are perpendicular. To prove that they are perpendicular, they must give you -1. If they are not giving you any value that is not -1, which means they are not perpendicular. So that's what actually you have to remember always. For you to determine whether two equations are perpendicular, you determine their slopes, and then you multiply their slopes, then you find the results, then you check, are their results equals to -1? If their results is not -1, which means they are not perpendicular. If their results are equal to -1, which means they are perpendicular. So that's how you determine it, okay? I hope I'm clear on that, okay? So let me retain the one that was there so that it will be clear when I share the slide, okay? Okay? So that's how you determine whether two equations are what? Are perpendicular, okay? All right. I hope we are together on that. So let's move on. Okay. So let's move on to the next part of our revision. Next part of our revision is quadratic equations. You need also to understand about the quadratic equations because you might also encounter the questions. Now we move from linear equations to quadratic equations. Quadratic equations are equations that have the form of ax squared plus bx plus c. So any equation that you can actually see that have got this form of x squared, ax squared plus bx plus c is equals to 0, then we call them quadratic equations. In other words, any equation that you have got the variable to the power 2, where highest power of the variable having the highest power of the variable to the power 2, then we call them quadratic equations. Whatever variable, it might be actually the quadratic that is in the form of y variable or in the form of x variable. So if you x variable, which means we actually having an x to the power 2 as the highest power, and then maybe we have got other constants or plus others attached to an x, then you can call that one a quadratic equation. Why we call it a quadratic? Because of this highest power of x to the power 2 that we have. Okay, so that's how we determine the quadratic. So that as long as it have got, you might have only this x, something like this. If I copy this one, let me paste it somewhere here. If I have the equation that you have x squared and say maybe plus what? Plus, let me say x squared plus 2. This equation, it's a quadratic equation. Why I'm saying it's a quadratic equation? Because it have got x squared, it have got an x that have got a highest power of 2. So once you have got a quadratic an equation that have got a variable that have got highest power of x to the power 2, and other variables, maybe constant or not constant, we call that one a quadratic equation, because this variable that is here got the highest degree of power of what? Of 2. Our variable is the highest degree of what? Of power 2. That's what determines whether that equation is a quadratic or not. So this actually determines whether it's a quadratic based on the power of this, highest power of our variable, which is the power 2. So other things that actually adding doesn't matter, are not the one that we are used to determine whether it's a quadratic. We use only this one to determine whether it's a quadratic. So it doesn't matter. It might be a y, it might be an x or a y. So if sometimes you find it written as a y, not x, isn't it? So I might use the y instead of x. So you might actually have, if I use y there, I might have y squared like this. It's a quadratic equation. Why? Because the variable that I have as y is of course the highest power of what? Of 2. So that becomes a quadratic. So it's a quadratic equation. That's how we determine whether something is quadratic. So you might also have maybe extended f2y plus what? Maybe plus something like this 0. Still, it's a quadratic what? Still, it's a quadratic equation. Why you are saying this one's a quadratic equation? Because my y variable is the highest power of what? Degree of what? Of 2. That's what determines whether it's a quadratic equation or not. Okay, so you mustn't confuse. It will be actually written in different words, but what you use to determine whether it's a quadratic, you determine the highest power. Once you find the variable with the highest power of 2, then added to some also terms, then you know it's a what? It's a quadratic equation already. Okay, that's how you use to determine whether it's a quadratic or not. Okay, I think my explanation is clear on that. Okay, so you should know How do you solve the quadratic equations? Solving, when you're talking about solving the quadratic equation, you actually want to determine the value of your variables. What is the value of your variable? So the quadratic equations, we have got different ways you can solve the quadratic equation. You can solve the quadratic equation using what you call the factorization. You can solve the quadratic equation using what you call the completing the square method, or you can also solve the quadratic equation using the quadratic formula. Quadratic formula, I think it's familiar. If you want it actually maths at high school, I think that one is familiar. I'm not sure if I'm still remembering it. Quadratic formula, we're using it at high school. So quadratic formula, we're going to actually check on that, okay? So using factorization is also simple. Simple factorization, if I give an example, like the example that I have here, say, you've got the equation, say, the quadratic equation saying x squared minus 2x minus 4 minus 24. And the question says solve for x values, okay? So what you have to do when you are given this, you need to determine two factors that if you multiply those two factors, it will give you this value. So two numbers, when you multiply them, they give you minus 24. Once you get these two numbers that if you multiply them, they give you minus 24, but if you add them, they give you minus 2. That's what you have to do. So the thing that you have to do now, you have to go and find the factors. The factors of what? Of minus 24, which if you multiply them, they give you minus 24. But if you add them, they give you minus what? Minus 2. So if you find them, myself, I find them and find out that the factors is 2, is 4, and what? And 6, and minus 6. So if you multiply and say, now if you say 4 times minus 6, you are going to get minus 24. If you want to prove, you can multiply it. On a side, you can get it. Okay? If I add and say 4 plus, if I say 4 plus minus 6, I'm going to get minus 2. You can prove it. If you want to prove me wrong, so once you get those two factors, then you can actually put them in as factors and say x plus what? Plus 4, and then x minus what? Depending on the signs of those two factors. Remember, I get my factors as 4 and what? And minus, I get my factors as 4 and minus 6. Those are factors. So when I'm taking these factors now that I get as factors of these, I'll simply replace this with the factors, which means x, because this x have got, this 4 have got plus. So which means I'm putting x and say x plus what? X plus 4, which is x what? X plus 4. Then this one, because it's minus 6, I'll be saying x minus what? Minus 6. That's why I put what? Minus 6. So I'm replacing the whole quadratic with these factors that I found here, because my quadratic have got factors. So I'm putting these factors here in place of what? In place of my quadratic. So I equate them to 0 and say they are equal to 0. So in place of the whole function of my quadratic, I'm simply going to put the functions of my factors, which is the factors that I found is the ones that I can actually, if I multiply them, they give me this. If I add them, they give me this, which is what? Minus 2. So that's what you have to determine. The factors, those factors, if you multiply them, they must give you this, minus 24. And if you multiply them, they must give you the value attached to what? To an x. That's how you actually determine whether you have got simple factorization. So this one we call it simple factorization, okay? So while we solve them now, once you actually find the factors, you can actually split them now and say x plus 4 is equal to 0, or x minus 6 is equal to what? Is equal to 0. Then now, you simply now jump, take this one to the other side of equal sign here, is going to be negative, which means now you've got x is equal to what? 0 minus what? Minus 4. Or this one also, you jump it to the next what? The other side of equal sign. You know what happens when you jump. It will change the status, okay? So it's going to change the status to negative. So it becomes 0 plus what? Plus 6. So now you've got the values of x as x is equal to what? Minus 4, and x is equal to what? Is equal to 6. So this is the value of what? Of your x. So that's how you solve for what? For x. When you're using simple factorization, whenever you have the quadratic that but not all quadratic solved by simple factorization. So other quadratic, you might not be able to apply simple factorization. That's why we have got other methods of solving the quadratic. We have other methods that we're gonna have a look now. Okay, so you should also know how to you can actually try it on yourself when you have got these slides. Apply it on this one. Apply simple factorization using a simple factorization of this question that I posed on my slide as well. Just try it on your time, okay? So the other method that you can also use another method called completing the square method. It's a very complex method. It's complicated. It's a bit complicated, but there's no way to escape it if the question says solve using completing the square method. So, but sometimes if you are not asked, if the question is not specified, you can actually use the simple way, either the quadratic formula, or you can use the simple factorization. But if it comes and say use this completing the square method, now life gonna become a little bit actually tense on your side. Okay, there's no way to avoid it. So if it's actually need to apply the completing the square method, how do you apply the completing the square method? You need to change the equation that we have and rewrite it in this form of the form of A is equals to x minus h squared plus what plus k, where this one actually are representing the constants. Okay, but to change to this form, you need to change it step by step. Okay, I have got an example. I'm going to show you on the example. I have this example. It says solve this one by completing the square method, using completing the square method. Okay, so completing the square method, how do you change? You have got this equation in this format, but you need to change step by step until you get to this form. Okay, how do you change it? The first thing that you have to do, you have to split those terms that you have got x value, you group them together. That's how you have to do. So if you check here, I group this one together because they have got an x. So I group them together. That's how you group with the bracket together. So which means you separate here and separate here. These ones, because they've got a variable x, you separate them. So I separate them because they've got the variable x. You group them together. That's the first step that you have to do. Okay? After that, you need now to divide this middle one, divide it by what? By 2, and then you square it. So you divide the value that you have here by 2, and then you say to the power 2. But when you say to the power 2, you add it and subtract it. So you add, if I say 4 divided by 2, I'll get 2. Then I'll say that 2 to the power 2. So I'll add it. So I'll retain the same value that I have. But inside here, I'll add the value that I divided and get as the answer here. Because I divided by 2, 4 divided by 2, I get 2. Then I'll say the answer that I'll get is 2. I'll add it inside here and say 2 squared, and then I'll subtract again and say 2 squared, which means I'll add the same and then I'll subtract the same. The same value, I add it and subtracted it. That's how you do it. Then you do it in the same bracket. But remember, this thing on the other side, outside the bracket, you retain as it is. But here you are playing around with the things inside your bracket. Okay? So once you do this, you come to the next step. The next step, you take this one outside the bracket. So when you take this one outside the bracket, obvious, 2 to the power what? 2 to the power 2. When you solve it, it's going to be 4, isn't it? So which means you are taking minus 4 outside the bracket here, which is minus 4. Which means inside here you are left with what? 2 squared, which is this 4. Which means you are left with what? 4 squared, which means 2 plus what? 2 times 2 becomes what? 4. Which means you are left with the one with the positive, which is plus 4. But the one with the negative, you are taking it outside the bracket here, which is now you are taking it and joining what? Minus what? Minus 13. Okay? That's the next step. So the next step now, you are simply combining minus 4 and minus what? Minus 13 becomes minus 17. That is simple addition. Okay? But now, inside here you are applying simple factorization. Simple factorization, you can actually find the factors that if you multiply them, they give you this one. And if you add them, they give you this one, which is actually 2. So we call them the square what? The square a square root, okay? So the square root of this fraction is simply the x plus what? X plus 2. So the x plus 2, in other words, you find the factors. If you multiply them, they give you 2, and if you add them, they give you 2. They give you this one mid one, which is 2. So which means the factors that you are going to get is x plus 2 and x plus 2. That's why we simply say it's an x plus 2 squared. It simply means we have got 2x plus 2s. So instead of writing x plus 2, we simply say x plus 2 what? X plus 2 squared. So in other words, we'll place this one with the factors, which is x plus 2 squared, okay? Then x plus 2 squared minus 17 outside, then plus what? Is equals to 0. Now I'm solving for x plus 2 squared. X plus 2 squared, I'm taking this one to the other side. You know what happens when you take to the other side? It changes the sign. I'm going to left with x plus 2 squared is equals to what? It's equals to 17. Minus 17 goes this side and then becomes part plus 17. It now becomes 17, okay? But how do I remove this square to the power 2? I have to say square root of both sides, okay? Square root of this side and square root of this side, which means that's how I remove this power 2, okay? So I'm left with x plus 2 is equals to plus or minus the square root of what? The other side, which is square root of 17, okay? But now I need to find for x. How do I find the value of x, which means now the value of x, I have to take this to the other side. This becomes what? X, which means my value of x is simply going to be x is equals to what? When I take to the other side of equal sign, is going to be negative. That's how it becomes negative 2 plus what? Plus what I have here, which is plus or minus square root of what? Square root 27 root square root of 17. Okay, so now my two answers, the other one is going to be the one that I say plus, which is this one, and the other one is going to be the one that I say minus. So this becomes my two answers of what? Of my x when I'm solving my my equation using the completing the square method. So you can solve this one using this completing the square method, or you can use the quadratic formula. Okay, I'm going to show you now the application of quadratic formula in the next slide. Okay, here that's how we solve using the completing. Then now you've got the values of x. So your answers, you can just retain it and give it out as like this. You leave your answers like this. You don't actually go further or solve with the calculator. You can just leave your answers like this. Then that's how you actually solve using the completing the square method. So you have to follow. Try actually to follow this one. I know it's a little bit complex. It needs much time to practice through it so that you grasp the concept of what completing the square method. It's not something that you just understand only 1 second, okay? But the simpler one, I think, it's a factorization and also quadratic. But it will be actually no way to escape it. Is the question needs you to apply completely the square method. But you know, it's a little bit complex, okay? So I need to show you how to use the quadratic formula. Quadratic formula, you know, I think this one everyone is familiar. Quadratic, in your equation, you need to identify what you call your A, you need to identify your C, and you need to identify the value of your B as well. So you need to rewrite your equation in this form, and then you identify your value that is attached to x squared, that's what you call A, and the value attached to x, which is what you call the B value, and then the constant, which is the C value. And then you substitute them into this formula. The quadratic formula is simply saying minus B plus or minus the square root of B squared minus 4AC all over 2A. That's how. So for you need to get this B, you need to get also C, you need to get also A, so that you substitute them into this formula, okay? So I have got an example that is here, and say, my example say, solve this equation by quadratic formula, which is 1 over 8x squared plus b plus x what. So in this equation, my a is 1 over what? 1 over 8. I have to identify this one with my a. My a is 1. Okay, I put 1 over 8 here. Okay, I used the 1 is 8. I used 8 as my. Okay, I used the wrong equation here. But I have to identify my a. Let's say here I've got x squared. My a is x squared. And here I have got also my b is 8. Let's say I've got 8 as my b. Okay, I have 8 as my b. Then here I have got also 20 as my constant. Okay, let me remove this one. I've got 20 as my constant. If I have 20 as my constant, so here in this equation that I have, simple one, I can identify my A as 1 because here A, in place of A here, A, they've got the value of 1. Then on X, attached on X is only 8. So I've got value 8, which is my B. And the C constant is what? Is minus 20. You take this one as your C. So now you can simply substitute now to your quadratic formula. Quadratic formula, which is minus B, which is minus B, which is minus 8, which is minus 8 plus or minus the square root of B squared, which is 8 squared minus 4, A, C, A is 1, then C is minus what? Minus 20. All divided by 2 times A, which is A1 here. That's what I'm doing here, putting all those values on my quadratic formula. Then it's equals to what? Minus 8 plus or minus the square root of, now we are adding this one, which is 8 squared is 64. You can use the calculator, get 64. Then minus 4 times 1 times minus 20 is going to give you plus 80. That's what I'm adding here, plus 80. Or over 2, 2 times 1, you are returning 2 at the bottom, okay? That's what you're returning. Then here it comes what? Minus 8 plus, when I'm adding 64 plus 80 is giving me 144. So I'm saying minus 8 plus or minus the square root of 144 divided by 2. Then the square root of 144, you're going to get 12. That's why I'm saying minus 8 plus or minus 12 plus over what? Over 2. Okay? Then which means my two values of X is simply going to be minus 20 over 2 or 4 over what? Over 2, which gives me minus 10 or what? Or 2 is my final answer. I think that's how you apply quadratic formula. Okay? I think it's simple. So I need you also to approach this question, which is solve what? Quadratic formula, which I have here. When you have this slide, so go through it as well. Okay, so I think that's all on what? On the quadratic that I have. Okay, so we have to check also on tangents and limits. We also have also the questions that comes from tangents. You need also to calculate also the tangent. What to call a tangent? I think you might actually have a look on this one. A tangent line is simply a line that touches an equation or a graph, but it doesn't cross a graph, but it touches it. Only touches at a point, but don't cross it. Once that line actually have a touch but doesn't cross, then we call it a tangent line. Okay, so you should know all the linear equation. You might actually have what to call a tangent. In any graph, you might actually have a tangent line. So a tangent line is simply also a linear equation. Okay, so a tangent line is a line that is actually in the form of y is equals mx plus what plus b, which is also a linear equation. So you should know also how to calculate the slope of a tangent line. Tangent line, you can also calculate the slope using what called the limit concept. The limit concept, you can simply use this formula called limit where x approaches a certain value. So a certain point is a point at where that tangent is touching that equation. Okay, so we can say fx minus fa over what? Over x minus a. So this is actually the concept that you can use to calculate a slope using the limit function in what? In a tangent line. Or you can calculate a slope using what we call the dy over dx. dy over dx is more like you are differentiating. So when you are differentiating your equation, you can actually substitute the values and then get the value that you are going to get becomes a slope of that tangent line. Okay, that's how you can get also a slope of what? Of a tangent line. Okay, so if you are calculating the equation, you can simply using the same concept. If you have got a slope and having a point, you can just use the same concept that we used when you're calculating the linear equation. What equation? Substituting the point here, and then you say substituting the slope, and then substituting also the what? The other x value, and you calculate what? You get your equation. So that's how you calculate also the slope. Okay, so the slope of a tangent line. Find the slope and the equation of a tangent line to the curve with the equation. So if, for example, I've got this equation saying fx is equals x squared. They say calculate the slope at x is equals to 1. So what it needs that you need to find the slope of a tangent line. Tangent line, you can use the same function called limit. So you are limiting at x approaches what? X approaches 1. So NA representing this value, which is x approaching what? Approaching 1. You put 1. But your fx here, fx is simply representing this x squared that we have as what? As x fx. So you simply put fx, then you simply put the substitution of fa. Fa is when you're putting 1 here. What you are going to get when you're putting 1, you're getting what? F1. Okay, so you substitute in your equation, then you are going to get something like this. So when you are substituting, you are going to get x squared. If you are substituting x squared minus 1 over x minus 1, you can actually cancel this one. This one you can actually determine x squared minus 1. You are going to get x minus 1. The factors of x squared minus 1, it becomes x squared minus 1 plus x minus x plus 1. Then which means this one, the top one, this one, and this one, they're going to cancel out, and then you are left what? With x plus 1 only. So x plus 1, that is the one that you are left with. So when you are solving now x plus 1, you simply now putting this 1 in place of x here. Then say x plus 1 is equal to what? 1 plus 1. Then you get 2 as what? As your slope. So when you are calculating there, if you are getting x2 as a slope, which means now your slope is 2, and then you have to find 1 point. 1 point when x is 1, you simply substitute in your equation. Then you find when x is 1, your y is supposed to be 1 as well. Then once you get this one, then you can simply now substitute in what into the equation. I need you to go through this one. I think our time, we are left with only a few minutes. I just want to rush a little bit so that, because there are some things that we need to talk about here. So you need also on the limits. I'm not sure if you went through the limits. So limits are very simple to find the limits. You might also ask you to find what you call the left hand limits or right hand limits. So the limits, when you're finding the limits is mainly indicated by this, which is this expression, which is lim x approaching what? Approaching a certain value here. So what it needed, you actually need to substitute that value. But before you substitute, you need to find whether there are factors which cancels each other when you are dividing. So once there are factors, you need to divide it, and then you left with the simplest form of your expression before you substitute this value into the expression to find the limit. For example, we can actually determine whether two equations, whether equations you've got is continuous or not continuous. So we say that an equation you've got a continuous, it's a continuous, or you've got a continuity when the left hand side and the right hand side limits you've got the same value. So that is the other thing that you have to determine when you have to find the limit. So the limit of a left value is determined by a negative sign here, which is to the power what? The power negative. And the positive, from the positive value, it's represented by to the power what? To the power positive. So which means this limit is approaching -2 from the positive side. That's what it means. And this limit is approaching a -2 from what? From the negative side. So this is what called the left hand limit and the right hand limit. That's what it means. It simply means this one is approaching from the negative side and the other one is approaching from the positive side. I'm not sure if you actually in your lecture that we're doing you did the limits, but that's what it means. So when you are solving, you need to determine the left hand side. So this bar is simply means this one is the positive side of what? You take the positive side of this one, which is simply going to be 5x plus what? Plus 10. But if you find the factors, you factorize 5x plus 10, it's going to give you, you factor out 5 and give you x plus 2 inside. And this x plus 2 is cancels each other with this one, and which means you are going to get limit what? Limit 5. But the limit of a constant that doesn't have x here, if it was having x, then you are going to put -2 in place of x now, and then you have 5 times what? Times -2. But this one is simply going to have 5, which is not attached to any value. Okay, so any limit of a constant is simply going to be the answer is going to be that constant. That's how we find the limit. If it's a constant that doesn't have x, which means the limit is answer is going to be that constant. Okay, so which means here you're going to get 5 as a constant. The same applies here. Approaching from the negative side, you're simply going to have this one. It means you put a negative outside because it's approaching from the negative side, which means this negative is going to multiply inside this 5x plus what? Plus 10. So you are going to get but now you can factor out 5. When you factor out 5, you are left with what? You are left with x. You are left with x plus what? X plus 2 inside here. But x plus 2 can cancel each other with x plus 2 at the bottom. So when it cancels each other, which means you are going to left with what? Limit of what? -5. Then your answer is simply going to be -5. So if you check here, this is a limit approaching from the negative side and the limit approaching from the positive side, but of the same what? Of the same expression. So once these ones is different, then you can actually conclude and say the limit does not exist between what? Between these two, within this expression, because the limit approaching from the negative side is not equal to the limit approaching from the what? From the positive side. For a limit to exist the limit approaching from the left side must be equal to the limit approaching from the positive side. Then you can say the limit exists of what? Of an expression of a certain what? A certain function. So that's how you also determine whether a limit exists given what? Given any expression. So you just know also how to solve a limit whenever you're given a limit of a function. Limit solving, whether you are not actually asked to determine whether a limit exists or what, you just actually asked to solve. You should know also how to solve it. For example, here it's saying solve the limit. You are given this limit. This actual limit you are given x approaches what? Approaches 2. You just know how to solve this limit when you are given any limit. Okay? To solve it, the first thing that you have to do, because if you rush to substitute 2 here, you get 0 at the bottom here, which is not required. So what it means, because if I substitute 2 here and say 2 squared, I'm going to get 4. Then 4 minus 4 is going to give me 0. Then that one, now you know it's a no-go area. It's not required. So what is required? You need to find the factors first here. To find the factors of this one at the bottom and the factors of this one on the numerator. Okay. So the factors, if you factorize this top, you're going to get the factors as x plus what? X minus 2 and 3x plus what? Plus 3 as your factors. Then if you factorize this one as well, find the factors of this one, you're going to factors as what? As x minus 2 and x plus 2. So you find out that this one and this one can cancel each other, and then you left only with 3x plus 5 and x plus what? X plus 3. But now it becomes easier. If you substitute, you take 2 and substitute in place of x now, it's no longer giving you 0. So now you can actually substitute. So you can actually, in place of 2 here, you put what? In place of x, you put it 2. So I put it 2 in place of x. Now in place of also x here, I put what? I put it 3, I put it 2. So that's how I put it what? 3 plus what? 3 times 2 plus what? Plus 5. Then I'm actually adding now. 3 times 2 gives me 6 plus what? Plus 5. And gives me 11 over what? Is 11 over 4 is my final answer of this limit. So that's how we solve a limit. So you need to determine whether it's not giving you 0 at the numerator. If it have got a fraction, determine at the denominator if you substitute directly if it's not giving you 0. If it's giving you 0, then you check whether there are factors that you need to factorize first and cancel each other. But if you substitute and not giving you 0, you can just go on and substitute directly from the equation. Like this one now, I have got also this one and saying, so solve this one. This one doesn't have a fraction, doesn't have a denominator, it's just a straight. So this one is very simple. When you're calculating this one, you simply substitute. You simply substitute these 2 in place of what? X. Then you simply x cubed plus what? Plus minus 4x plus what? Plus 11. Then you get your answer. You just directly substitute. You don't have to do anything here. You simply put x in place of 2 and get your answer. That's how you solve this limit here. Okay? So you should know how to solve this limit. So you can also try this one when you get this slide. Okay? Okay. So the other part you can also use what? The other chapter is the derivatives. You need to know how to find the derivatives. Differentiation. So the chapter of differentiation, I'm not sure if you did also differentiation. Okay, differentiation you should know when you are solving also the calculation of differentiation. We left with actually a couple of minutes. So very sorry because I'm actually too fast now. We just want to make sure at least we address these 2 chapters that are left. At least we did maybe 2 examples so that I explain how you solve those how you do differentiation as well as what integration before we end up this chapter. I think you have got another lecture, isn't it?
Yes, we've got one.
All right.
At 10 o'clock, yeah.
All right, thanks. So let's just try to utilize what we have to address on these 2 chapters so that I'm just actually go through maybe 2 examples so that you understand how we solve using differentiation. Okay, so differentiation, what it means when you are actually differentiating, you might actually have a question that comes to you like this one. I'm no longer a differentiation sometimes is represented by this symbol. So whenever you're actually seeing this symbol saying f bar x, it simply means differentiation. It simply means differentiate. Or it might actually written in this way and say find y bar. If we have got an equation that is saying y is equal to something, and then they say find y bar, they simply means differentiate. Or sometimes they simply write it in this format and say find dy dx. They simply mean differentiate, or they might actually say find d of fx dx. They simply mean say differentiate. So differentiation question are actually asked in different notation. They might actually ask you using y bar, or ask you saying find dy dx, or find the dy over dx. They simply mean differentiate. Okay, so what do we mean when we say differentiate now? Okay, sometimes you can actually finding a slope using differentiation, or finding what we call the rate of change using differentiation. Look, the example that I have here, it's saying find the rate of change of fx is equal to x squared plus what? Minus 2x minus 24 at x is equal to 2. So when you are finding the rate of change, it simply means you have to differentiate this function, and then after you differentiate, you now substitute x with 2 to find the actual value of the rate of change. Okay, so like here, the differentiation, you simply differentiate either dy dx. And how do you differentiate? When you are differentiating, guys, you look at each and every term. So we come at this one where you have got an x. So the first term, I come to x squared. X squared, I'll check what is the power of x squared. The power of x squared is 2. So I'll take the power, and then I'll write here, I'll write the power here, and say, and take the power and say 2x. Then x, this one, once I write x, then I'll subtract the power minus 1 and say 2 minus 1. And I left with 1. So which means now I'll be having 2x to the power 1. Then I move to the next one. The next one is simply minus what? Minus 2x. Which means this minus 2x simply means it's having x to the power 1. So, which means if I subtract 1 to that power, I left with 0. That's how I left with the minus 2 without an x here. So, but this 24, since it doesn't have an x, when I'm differentiating, I don't have to check on that term that doesn't have an x at all. I'll simply throw it away because it doesn't have an x. So you differentiate only on those variables, or only on those terms that have got an x variable. Or that's where you have to focus on when you're differentiating. So you focus only on these two. That's why you differentiate and get 2x minus what? Minus 2. So now once you get this answer, for you to calculate the rate of change at x equals 2, you now have to substitute 2 in place of x. Then you put x in place of what? In place of x, you get 2 times what? Times 2 minus 2. Then you get 4 minus what? Minus 2. Then you get 2. That's how you get what? The rate of change. The rate of change of a certain what? Value. You differentiate first, then now you substitute that value, then you get the rate of change. So if you get the question of finding the rate of change, you have to differentiate, and then after that you substitute the value. Okay, you might actually find also the question and say find the derivative of this, isn't it? Differentiating. So when you are differentiating, you should know what to do. Okay, you focus at each and every term. So here I simply actually show you step by step how we differentiate on my solution here. Okay, so what you have to do, you focus on this one first term, which is what? 2x to the power what? To the power 5. Okay, so what you have to do here, the first thing that you have to do, you take this one 5, which is the power 5, and you write it and say 5. Then you say times what? Times 2, which is already here. I already have 2, which is 2x. Then I already have what? 2x. Then you repeat that, you return this 2x. Then to the power what? To the power original, which is 5 minus what? Minus 1. That's how you write it, differentiating. So which means this is how you differentiate the first one, which is this one. Okay? I move to the second one, which is minus what? X squared. Which means minus x squared here. I'll take the power, which is 4, and I'll write the power here, which is 4. Then I'll say times what? Times x to the power original minus what? Minus 1. So in differentiation, you'll be actually subtracting 1 at each and every power. You subtract minus 1 when you're differentiating. So you take the power and write it, multiply with that power, and then you subtract minus 1 to the power. So you move to the next one. The next one here, I'll take the power, which is 3. Then I multiply it with it, which is 3. Then I'll return 3x squared, 3x, which is this one. Okay, 3x. Then I'll say to the power 3 minus what? Minus 1. Then I'll move to the next one, which is 6x. 6x, I'll take the power. 6x means if it's the power of 1. So I'll say 1 times what? Times 6x, I'll turn 6x. 6x, this x, you have the power of what? 1 minus what? Minus 1. This one doesn't have x, so I throw it away. When I'm differentiating, I throw it away. So now I'm solving this one. Solving this one is simply going to be 5 times 2, then get me 10. 5 minus 2 here get me 4. That's how I get what? 10x to the power 4. Then I'll move to the next one here. 4 times x to the power 4 minus what? That's how I get 4x squared cubed. Okay? I'll move to the next one here. That's how I get what? 3 times 3. That's how I get 9x what squared. Then I'll move to the next one. This is x what? That's how I get what? 6. So this is the result of my differentiation. When I'm differentiating this one, I'm going to get to this one. So you should know actually step by step what do you mean when you say differentiate, and what are the concept of differentiating. Your focus should be on those powers of what? Of x altogether. Okay, so this is how we differentiate. I think you understand. On my example there, I tried to emphasize on that. Okay, I think we don't have much time. Let me just talk about what you should also know about what the derivative of what? Of cosine, sine. The derivative of a sine, it's unfortunate that we don't have much time on our side for us to go through everything. But for a minute, let me just steal a minute of yours, guys, just to explain about integration. A minute of yours. Just allow me just to steal a minute of yours before I share my contacts with you. Okay, integration, guys, is different from what? Differentiation. It's a reverse of differentiation. So you might actually find also in integration where you say integrate something like this, where you have got a limit on a power on top and the lower limit. So what it means, you have to integrate this one and then you substitute as in your values. Okay, so when you are integrating, now it's vice versa to your differentiation. You are adding something to your power. So in your power, you add 1, and then you divide by the total power. That's what we call integration. So integration is simply, if you have got 6x and say integrate, this symbol here means integration, this one. So integration is simply in whatever that you have here. In the power of x, you are adding 1, and then you divide with the total power. So integration simply means I have got the power of what? 2. Then I'm adding 1, and then I'll divide with the power now, the new power, which is 2 plus 1. Then which means I'm going to get 6x to the power what? To the power 3 divided by 3, divided by 3. Then when I'm dividing by 3, I'm going to get what? When I'm dividing by 3, I'm going to get I'm dividing here by 3. When I'm dividing, since I have got this limit, which is 3 and what? And 1. What does this limit mean? It means after I differentiate, you have to put the upper limit and say minus the lower limit, which means now I substitute this 3, which is the upper limit, inside in place of x, which means I'm saying in place of x, I'm putting 3, which means 6 times 3 to the power 3 over 3. Then I'll say minus the substitution of the lower limit, which means now I'm substituting 1 again to the same results, which means 6 times 1 to the power 3 minus what? Minus 3. So I'm solving this one, and then minusing this one with the lower limit. Okay, so I'm getting 162 over 3 minus 6 over what? Over 3. Then my answer is simply going to be 54 over 2. Then I get 52. So that's how I solve also integration when we have got the limits. So we have got so integration that doesn't have a limit, but it's unfortunate we don't have much time, guys. Sorry for that. We could have actually go through everything, but I hope you are going to go through these slides and focus on my example that I put on this as examples, and solve also the question that I put on this slide. Time is limited for us, but I'm apologizing for that. I'm very sorry, guys. Let me just share my number. I think my email on the first slide. Everyone, before we call it a day, just take my email here, guys. Just write my email. This is my email, and also take my number. My number is 07. My number here, the one that I'm writing on my screen now. Just take my number. My number is 0. Okay. My number is 0742310 364. Okay, that's my number. The number that I'm writing, this is my number, guys. You can just WhatsApp me there, then I can forward this slide for you so that you can go through the slide. Or you can just communicate with me on my email, Richfields, Silas at t@richfield.ac.za. Then I'll share with the slide. Provided you don't have access to access the slide on the maths group, then you just communicate with me. Then I'll forward the slide to you either through WhatsApp or through email. This is my email and my cell phone number. So thank you guys for being with you today. It's unfortunate that the time is limited for the whole module for revision. There's a lot that you actually have to. We could actually went through in our module for revision. But I just hope at least in the previous workshop you were covering most of the stuff. So I assume at least it helped you a lot. Thank you guys for being with you today. Any question before I call it a day?
Yes, sir.
Yes.
Yeah, just double checking. Where is the exam going to be more much based?
The exam is going to be all the chapters, but all the chapters it's gonna be. You see all these things that I was giving you as example. Even integration, yes. Integration, differentiation. You saw when I'm talking about integration, they're gonna give you even simple stuff and say, like even the likes of. Let me just go quickly to the last part there. I think on integration, you see on differentiation, they might actually even give you something like you see like this one, like this one, the one that I'm giving you like this one. They might give you something like this one and say solve this one and find the integration of this one. So you should know when they're giving you something like this one that you've got integration with the power and the bottom. You should know how to solve those ones because you might actually get integration, those questions that you've got part of this one. So we call this one definite because you are going to integrate. Then after that, you have to substitute these two and one in order to solve the actual value. So you should know how to play around with all those concepts that you've got integration. The same applies differentiation. You are going to get also differentiation where maybe you have to find also the differentiation of of the rate of change and the limit. Differentiation, you see the example that I'll give you as the rate of change. It's jumping a little bit there. Very sorry, I'm taking up your time for all right, differentiation. Okay, derivative. You see these ones for rate of change. You just have to check as well. It might be not the big equation like this. They might actually say they give you the equation which might maybe have x squared or 2x squared or something. Then where x is equals to 1, then they say find the rate of change. You should know you have to differentiate. Then after that you substitute that value. Or you might actually even give and say only the derivative. They just want to find what the differentiation. So they might actually give and say y is equals to 2x to the power 5 and say differentiate, which means you should know how to differentiate it. Differentiation, which means you can apply this one, then you get the answer is simply 10x to the power 4. So you should know those simple stuff. Differentiation, how to apply the concept of differentiation. Like even the example, they might give you maybe 2x to the power 2 and say minus 2, then define the derivative. Then you should know actually how just to differentiate. The limit, so it's going to cover everything, even on slopes. Those slopes, you should actually know how to calculate the slopes when you're given the points. Mean, how to calculate also the difference between 2 points. You should know those things. Midpoint, you should know. You might going to get maybe simple questions based on those stuff. That's why actually I created this slide in order to go through everything in terms of revision for you to gain knowledge about the overview of the whole material. Am I clear on that? Am I clear, guys?
Very, very clear, sir. I'm clear. I'm the one who asked the question. Very clear.
All right. Any more question? Because I think you are late for another lecture already, guys. So okay, I hope you have got my number, you've got my email. Please.
Okay.
Communicate with me so that I send you this slide. Definitely before Monday, I'll send you a slide. When you just